This scene starts with 3 empty spawn pads. A real Unreal Engine 5.5 C++ timer creates 1 actor, then 2 more, and stops at exactly 3. The counter, colored items, labels, and runtime logs all update from the compiled spawn path. In this lesson, we will store a spawn class with TSubclassOf, schedule repeated work with FTimerManager, calculate deterministic locations, call SpawnActor safely, initialize each result, broadcast progress, and clear the timer when the job is complete. The spawner stores a TSubclass of SpawnActor. That property is a type-safe Unreal class reference, not an instance. Its default value points to our C++ item class, but a designer could later replace it with a compatible blueprint subclass. Before spawning, the code checks that the class exists. This keeps asset selection outside the spawn algorithm while preserving a compile-time relationship with the expected base class. Begin play asks the world's timer manager to call spawn next item. The rate is 0.8 seconds, looping is true, and the first delay is 3 seconds, so the empty stage remains visible before spawning begins. The FTimer handle identifies this scheduled job. We do not need tick for the spawner, because nothing should run every frame. The timer expresses the real requirement directly: execute 1 bounded action at a controlled interval. Each location comes from 1 pure calculation, origin plus step multiplied by the 0-based index. The origin is y minus 300. The step adds 300 centimeters on y. Index 0 produces minus 300, index 1 produces 0, and index 2 produces positive 300. Because the calculation has no world dependency, the automation test verifies all 3 positions instantly. The runtime log then proves that SpawnActor used those exact locations. SpawnNextItem calculates the location, builds spawn parameters, and calls getWorld SpawnActor with the selected class. Always spawn is explicit because these demonstration items have no collision and each target pad is known to be clear. The result pointer is checked before any follow-up work. On success, the count increments, the new actor receives its item number and color, and the spawner broadcasts the updated total. On failure, the error log identifies the requested index. After each successful spawn, the code compares spawned count with max items. When the count reaches 3, clear timer stops future callbacks and the log records timer active false. This completion rule is not optional. A looping timer without a terminal condition would keep creating actors, growing memory and changing gameplay forever. The same handle used to schedule the work is the handle used to cancel it cleanly. These are 3 real frames from the saved spawn timer map. First, all 3 pads are empty and the counter reads 0 of 3. After the first timer callback, item 1 appears on the cyan pad. After the final callback, 3 differently colored actors occupy all 3 pads, and the counter reads 3 of 3. The fixed camera and fixed paths make the change easy to audit. These actors were created by the real compiled SpawnActor calls. The runtime log records the class, indices 1 through 3, all 3 locations, every counter update, and the completed timer state. Unreal Automation separately verifies the default spawn class, maximum item count, interval, all calculated positions, and negative index clamping. The test passed with 1 success and 0 failures. The video result, state trace, and deterministic test agree, so a pretty frame is not being mistaken for a working spawn system. The reusable pattern is 4 steps. Choose an allowed class with TSubclassOf. Schedule a focused callback with TimerManager. Spawn 1 checked instance at a deterministic transform. Stop the timer when the bounded job is finished. Broadcast progress instead of hard-coding the counter display into the spawner. This small structure scales to enemy waves, pickup respawns, effects, projectiles, and procedural level events while remaining easy to test and diagnose.